Let's review our homework problem 4. So homework problem is to write mathematical proof for the following facts. The first one is Newton's binomial theorem. From Newton's binomial theorem, we can conclude that the Taylor series of this one over 1 minus x to the n, can be written in this way. So uh, let's review this fact. Newton's binomial theorem is this is a review for any b is a number, any number, any number, and a then 1 plus a, the bth power is uh, this this p is this one, and a is there, and k is running from 0 to infinity. Uh, this is a generalized Newton's binomial theorem. So by applying this formula, we can say that 1 minus x, so this one is in fact 1 minus k. This one is equal to this one, okay? So 1 over 1 minus x to the n, uh, this is using the minus sign, minus n, this one. And then this one is, so this minus sign can be uh, written as this one. So this is 1 plus. So this is 1 plus minus x. Mm, okay. And then as you know, minus x to the kth power is this minus one can come out as like this. Also, this one can be written this because AB s power is AS power times BS power. So this minus 1 n's power, k's power, and this x is k's power. Okay, now we are ready to prove this formula, okay? So this one is 1 minus x and 1. This one is in mathematical notation. This is by adding minus sign, this one is this one. And then according to Newton's binomial theorem, so this is our B, and this is 1 plus minus x is our A. So this one is from minus n, choose k, learning from, and minus x. K's power is expressed as a product of those two. Now, now this one, and this one is can be re-expressed as n plus k minus 1, choose k. So this is the vital fact for this 1 minus x to the n 1 over. And this one is a power series uh, expression. So this is the key feature. And then by definition, let's calculate this one. So there is an internet delay. Okay. Let's prove this one. So those two, those two can be rewritten like this, and this is y. So by definition, uh, this is general binomial coefficient one. So suppose this is alpha. So so this is k. So in this case, this is n. But let's uh, find out this one. Okay. Then this one is alpha times alpha minus 1 times alpha minus 2 times up to alpha minus k plus 1. So in, in numerator, there are k many, k many. The first one is alpha. So since there are k many product, so the last one is alpha minus k, but we must add one more, because this one is alpha minus 0. This is alpha minus 0. So the last one must be alpha minus k plus 1. So that this is important. And then the denominator, denominator is this is k factor. So this is the uh, binomial coefficient. So if this is k, then this is k factorial, n is k. Okay. So this is definition by definition. So let's find out what is this one. This one is by definition. The numerator is minus n first one, and the next one is minus n minus one. Next one is minus n minus two. And since there are k many product, the last one is minus n minus k plus. Okay, so there are k many product, and denominator is k factor. Okay. Then look at this. The numerator is minus n minus one, and then minus n minus two, so that minus n minus k plus one, k factorial. This one can be related. So let's pick up minus sign from this one. So then this one is uh, written as minus 1 times n. Okay. What is it? This one is minus 1 times and what? N plus 1. Okay. So this one is, we pick up minus 1 then. The next one is n plus 2. Plus this one is, so this is minus n plus 2. Okay. So the last one is if we choose minus 1 sign out there, and this is n, this is plus k, and that is minus 1. So the last one is minus 1 minus n plus k minus 1. Then how many minus 1s are there? There are minus 1. Then the number of minus is, there are k many minus 1 sign there. Okay, then from here, you get minus 1 k's power, and the remainder is this one. And there is another minus 1 k. So the minus 1 to the k's power times minus 1 k's power is, what is this? This is plus, okay? Because this is minus 1, 2k. 2k is a even number. So this one is, so minus 1, k is minus 1, 2k times, okay, minus 1. Okay, so this is Anyway, this is even number, so this must be plus one. So this is cancelled out, cancelled out. Now what's the remainder? What's the remain one is, can say, from the numerator, there appears, okay, n survive, n plus one survive, and n plus two survive. Finally, the last one is n plus k. N plus k minus one survive. Sorry, what happened? And there is the internet problem already. Also, the remainder is k factorial. Okay. Then, as you see, this is the increasing order, increasing order. But when you consider decreasing order, the largest one is n plus k minus one. The largest one, this one is, and there are k many factors. So if you rearrange it, let's let's write this one in this way. So write down the largest one first. So this is plus k minus 1 is the largest one. The next one is n plus k minus 2. And then n plus 1, the smallest one is now n. Okay, this. So you can rewrite it as it is. And then look at this. This one is from n plus k minus 1. There are k many factors. So by definition, this one can be rewritten as this one. By definition, the largest one is n plus k minus 1 and k. Look at it. This one is exactly equal to this one, okay? Because the largest one is this one. The numerator, there are n many, k many decreasing factors, and the denominator is k factorial. So this is exactly equal to this one. That's the reason why the product of those two can be expressed as n plus k minus 1 choose k. So this is the key point. So we prove minus x to the minus n is can be expressed as the power series like this. So this one can be derived from Newton's uh, general binomial theorem. But there is another way to find out the power series expansion of this one. So using the Taylor series, uh, what is the Taylor series of this one? I mean, what is the uh, power series expansion for this one? Okay, then we will prove this one. But as you know, this is minus 1 minus x minus. Now, now we want to use a Taylor series. Then so the starting point is 1 minus x multiplied this one minus x, and the difference is plus x, okay? And this is x. The 1 plus x is x. So this is minus, and then minus x squared. And then what's the difference? Difference is cancelled out. This is an x squared. Okay, plus an x squared, then 1 more times x squared is x squared, and minus x times x squared is minus x cubed, something like that. So from this kind of a long division, now we have this. So this is the starting point. Then take derivative of both sides. What is the derivative of this one? What is the derivative of last one? So the next one is the derivative of one is 0, the derivative of x is 1. The derivative of x squared is plus 2x. The derivative of x cubed is 3 times x like this. Then what's the left? Left one is minus x minus 1. The derivative is, so this minus 1 comes out, and 1 minus x subtract, so minus 2. And then the derivative of the inside one, that is 1 minus, that is minus 1. So minus 1 times minus 1 cancel out. So there is minus x to the minus 2. So that is 1 minus x square 1. Okay. So in this way, 1 over 1 minus x squared is the Taylor series is this one. And then repeating this kind of uh, the left hand side um, differentiation and right hand side differentiation, uh, you can get the same result. So just I just wanted to skip this one, but I just wanted to give you the main ideas from this kind of geometric series. And by taking the derivative repeatedly, one by one, and then using binomial theorem, you can get this kind of thing. Okay, so this one can be rewritten. This is general one. Sigma k is 0, infinity, in general m plus k minus 1, k x to k. Okay, so when k is 0, you have this one. When k is 0, and plus minus 1 0. This is the when k is 1, this is when x variable here. When k is 1, then this is choose 1. When k is 2, you have this one. In general, when k is k, you have this. Okay. So from Newton's Taylor series, you can get the exactly same formula. Okay, let's define uh, using two parentheses. Let this be this one. So let's define this one as this one. Okay, and plus k minus 1 k, and then that is exactly equal to this. I mean, suppose n choose a is equal to n choose n minus a. Why this is the same? Because suppose you have many objects, and choose a is choose a choose a. But if you take out this one, left out is minus a. So from n set, choose a means choose A and choose minus n simultaneously. Because if you take out A, then the n minus this is left it out. Okay, so that's the reason why n choose the possible numbers of n choose A is equal to n minus A. So from this one is n plus k minus 1, and so you're using this kind of thing, then this is n plus k minus 1 minus 1 k. Okay. Because as this, then the k is cancelled out. So that's the reason why n minus 1 is left out. So this is equal to n plus k minus 1, choose n minus 1. Both are the same. Both values are the same. And then we use this symbol to denote this one. And then there is a very important combinatorial interpretation for this one. Okay, for this one. So that is the number of possible number of ways to choose k element from n-type set. N-type set. For, for example, so uh, now if we admit this fact, then the generating function for so this is the internet problem. It's interesting. It's this one, okay? So by simply using this notation, you can get this kind of like a beautiful expression. Okay. Then uh, the the this is the combinatorial interpretation. This one is in fact the possible number of ways to k out of n with repetition. So this choose k with repetition. So we say this is equal to formula this one. But I will explain this one more time in the classroom. But today's our examination, our quiz problem, wanted to concentrate on the binomial expression of this one using Newton's generalized binomial theorem. Also, by taking derivative from this one, you can get the same result. And then briefly, let's say, explain this one. Well, why n choose k with repetition is this kind of thing. Okay, so suppose n choose k with repetition means there are n types of uh, object. Okay, so there are n from the box. There are n box. Okay, there are n box. This is the apple, and this is a banana, and this is a pears, and like this. So from this n box, just choose k object from this n box. Okay, so in this case, you can choose k apples. Also, you can choose k banana. So there is a repetition is allowed. Repetition is allowed. So n choose k with repetition means there are n types of apples. Then just choose k n types of fruit. Yeah, n types of fruit. Just k and choose k fruit. So you can get all the apples or all the banana like this. Okay, so choose k. Then this one is equal to just like this. So suppose consider this kind of thing. So suppose you have k, you have three types of fruit. So suppose there are apples, banana, and that is carrot. Okay, a and banana and carrot. So there are three types of three types of uh, okay, this is pears, okay, but that is a carrot. That doesn't matter. And we want to take out five many fruit. Then let this be like this. Then look at this. Look at this kind of notation. The first one, and take bar and two and take bar, and there is two. Then the first one is apples. The second one is orange or banana. Okay, let's apple and orange and pears. And this one. Okay, so using this kind of bar notation, this one. So there are two apples, one orange, and two pears, like this. So in this way, how many objects? This is one, and just count about 2, 3, 4, 5, 6, 7. Okay. So there are Now this one is equals 1, 2, 3, 4, 5, 6, 7. So just choose bar. There are seven possible uh, uh, position. If you choose this one and this one as a bar as as a bar, then that means there are one apples, two orange, and two pears. So this one is exact can be reinterpreted in this way. So there are seven possible place, and just choose two place, and then you put bars at the place. Okay, you put bars there, and the left hand bar, this the first one is orange apples, and this one is orange, and the last one is pears. So this one can be interpreted very nicely. So when you have n types of fruit, and you take k out from here, then just consider n plus k minus 1 possible place. So in this case, this one is 7k. So just consider 7 place. So in this case, this one is n plus k minus 1, that is 7. And then just choose what? N minus, n minus. N minus 1 is, there are 3 types, but now we have, this is 2 types. So just take 2 in this way. Now I want to choose this one, and I want to choose this one. So there is, then that means if you choose a colored in this way, that means this is 2 apples, 1 orange, and this is 2 pears. So you can reinterpret this one in this way. So from 7 possible place, just choose 2 triangle and color like this. Then the white one is the two left hand side, 2 means 2 apples. The middle one means 1 orange. The last one is 2 pears. So in this way, we can very nicely we can say, if you choose n types, there are n types of fruit, and you can get out k many fruits. Then that means just take out consider this many possible uh, triangle like this. Then so take out n minus 1 triangle and color in this way. And then the left hand side one is the first fruit, this is the second fruit, and the last one is the last fruit. Okay. But this one is equal to what? N plus k minus 1 k, as I already explained. So n choose a is equal to n choose n minus a. So this one is equal to this one. That's the reason why m plus k minus 1, choose k is, say, and choose k like this. There are n types of fruit, and just to take out k many fruits. So this one, from this formula, you can get the answer, the possible number of ways to choose k fruits from n types of fruit. Okay, thank you very much for your attention.